sometimes we're given functions that are actually products of functions. That means two functions multiplied together. So an example would be y equals x squared times by the cosine of 3x. So there we've got a product. X squared is one function multiplied by the cosine of 3x, a second function. Usually we write this as u v. And there is a formula which we can use to be able to differentiate this. dy by dx is u dv by dx plus v times by du by dx. So every time we've got a product, we can use this formula. We've identified u with x squared. We've identified v with cos 3x. So what we need to do now is write down those derivatives. So du by dx, u we've identified as x squared, so du by dx is 2x. dv by dx, we identified v as cos 3x, so we need to write down the derivative of dv by dx. And we know that that will be minus 3 sine 3x. And now we can put these two together with these two into this formula. So let's do that. dy by dx is equal to u, that's x squared, times dv by dx, so it's times by minus 3 sine 3x, plus v, that's cos 3x, times by du by dx, that's 2x. Now this looks ugly, and really we need to tidy it up a little bit. We want to write these terms in a nice order, but at the same time we want to try and identify any common factors that there are. The reason is that what you might want to do is solve an equation like this by putting it equal to 0 to find solutions for maxima and minima. So it's important to be able to spot the common factors and take them out. And if we look in this term, we've got an x squared, and in this term we've got an x. So we've actually got a common factor of x, and we can take that out and put it at the front of the bracket. So x, and then a bracket. And let's think what we've got left here. We've got minus 3 and an x. So we have minus 3x sine 3x plus, now we took out the x, so we've got the 2 left to multiply by the cos 3x, and so we have 2 cos 3x, and we've closed the bracket. And there we've got that finished. And it's in a nice factorised form, so that if we wanted to do something more with it, as I said, find a maxima or a minimum, we could go on and do that. Let's have a look at another example. This time, let's have a look at one where we've got all just functions of x. No trig functions in, just nice functions of x. Except we'll make this one have a fractional index. We'll make it be to the power a half. In other words, it's a square root. So, y is a u times a v. So let's try and get into the habit of identifying these functions very specifically. So we've identified the two bits that are being multiplied together to make the product, u and v. Now let's do their derivatives. du by dx is 3x squared. Remember, multiply by the index and take one off it, so that gives us a 3x squared. dv by dx this one's going to be a little bit different. We've got a half there, and we've got a minus x in there. Making use of our idea of function of a function, we differentiate this inside, so that's the derivative of minus x is minus 1. And then we must differentiate this, so we get a half times 4 minus x, and we take 1 away from a half, that gives us minus a half. Let's quote our formula. dy by dx is equal to, and we know that it's u dv by dx plus v du by dx. And we can now plug in the bits that we need. So we've u is x cubed times by this minus 1/2 of 4 minus x to the minus a half plus v du by dx, that's 4 minus x to the half times by 3x squared. Now again, this doesn't look a nice lump of algebra. Really, we might have to do something with it later on, and if we did have to do something with it later on, we'd need it to look a lot better. We'd need it to look a lot nicer. So, I'm going to go on to a new sheet, and I'm going to rewrite this at the top of the page, and then we're going to have a look at how we might simplify it. So, dy by dx is equal to x cubed times minus a half, 4 minus x to the minus a half, plus, now we have v, which was 4 minus x to the half, times du by dx, which was 3x squared. And we want to put all this together. It's this term which doesn't look awfully good. Let's remember that to the power minus a half means that it's in the denominator. So we have minus x cubed over 2 times 4 minus x to the half. Plus, we haven't done anything with this side yet, so we can leave it as it is. And what we want to do is put everything over this denominator, 2 times 4 minus x to the half. We treat this as though it's over a denominator of 1. So our common denominator will be 2, 4 minus x to the half. This stays just the same, no problem. We haven't done anything with the denominator, so we don't do anything with the top. Plus, but this, we have multiplied a 1 here by this. So we must multiply everything here. So 2 times the 3 is going to give us 6x squared. And then we have 4 minus x to the power a half multiplied by 4 minus x to the power a half. So that just gives us 4 minus x. Because if we had the half and the half together, that's 1. And to the power 1 is just traditionally written as just 4 minus x. Equals. The denominator can stay the same. We've now got it all over this common denominator. And we can look at what we've got on the top. Again, we're looking for the idea of a common factor. Can we take out a common factor? And yes, we can. There's an x squared there, and there's an x squared inside that x cubed. X cubed is x squared times by x. So we can pull out that x squared. Then what are we left with? If I take out the x squared out of this bracket, I've got 6 times by 4, which is 24. And I've got 6 times by minus x, which is minus 6x. But I mustn't forget, if I take an x squared out of here, I've also got another minus x left. So altogether, that's minus 7x. And again, that's in a nice tidy form, so that if we need to, next time we can actually do something else with it. We could put this equal to 0 and take the top and solve it. We'll just look at one more example. Let's take y equals 1 minus x cubed all times by e to the 2x. First of all, let's identify our u and our v. So we'll put that u is going to be equal to 1 minus x cubed, and that v is going to be equal to e to the 2x. And now we differentiate u. So we have du by dx is equal to, the derivative of 1 is 0, because 1 is a constant, and the derivative of minus x cubed is minus 3x squared. We want the derivative of v. V is e to the 2x, and remember that in order to differentiate the exponential function, we differentiate the power, and we multiply the derivative of that power by e to the 2x in this case. So that dv by dx is equal to the derivative of the power, the derivative of 2x, which is just 2, times by e to the 2x. Now let's remember our formula, that if y is equal to u times by v, then dy by dx is equal to u dv by dx plus v du by dx. So we've got u, we've got dv by dx, we've got v, and we've got du by dx here. So let's make those substitutions. Dy by dx is equal to u to begin with, that's 1 minus x cubed, times by, and we want the derivative of v, dv by dx, so that's here, 2 times e to the power 2x, plus, and now we want v, that's e to the 2x, and now we want du by dx, and that's minus 3x squared. So that's times by minus 3x squared. And as we've done before, let's look for any common factors that there might be. And here we've got a common factor of e to the 2x in each term. So let's take that out, e to the 2x, which will leave us with, well, here we've got 2 times by 1 minus x cubed. So let's do that multiplication. So we've got 2 times by 1, minus 2 times by x cubed. And then from this one, we've got minus 3x squared. So we'll put that minus 3x squared. And it's usual when you've got an expression like this, a polynomial in terms of x, to write it so that we've got the powers of x in some kind of order. And in this case, I'll write them in ascending order from the smallest powers of x up to the largest. So that would be 2 minus 3x squared minus 2x cubed. And being factorised, that derivative is now in a position where we can use it for other things, perhaps to solve dy by dx equals 0.